Hello, everyone. Let's take a look at some homework questions from section 1.5, in which we solve inequalities. Check the Blackboard course for a full lecture from Professor Steele, but I'll just be showing some kind of homework help here. So, to solve an inequality, we want to get the x by itself. So first the 2x by itself. Subtract 6 from both sides. We get 2x is greater than 8. Divide out the coefficient now. To get x is greater than 4. So they'll ask for a few things in ALEKS. One is the number line. One mistake that students make is they'll choose the wrong parenthesis or bracket. Here it's a parenthesis, but we need to choose the opening parenthesis. Because x is greater than 4, we have the sign pointing us to the right, so we'll shade to the right. So first we pick up that opening parenthesis, put it right on 4, and then click that little little star kind of button with a line between it, and shade in this region, because this is going from 4 to infinity. Do not put a parenthesis here around infinity or at the end of the number line. We will put that into the interval notation, but not on the number line. ALEKS will count it wrong if you put a parenthesis here. It's a common mistake. Then we are asked for the, what do you call it? Well, let's do the interval notation, where we go from 4 to infinity. Oh, set builder. So the interval notation is that we go from 4 to infinity. Parenthesis at 4, parenthesis around infinity. Infinity always gets a parenthesis. The set builder, you'll have the little set builder button to choose from. And so this is x such that, that's the vertical bar, and then x is greater than 4. This is in the set builder braces, I believe, or brackets. So you just have to click the set builder button and then put an X here. And in that second field, you click the inequality symbol that you need. And there's number 1. Let's look at another example. One in which we have to divide by a negative. So first we subtract the 3. To get negative 5x is greater than 55. We divide both sides by negative 5, but when we divide by a negative, this is where we flip the sign. So the sign is now opening the other way. 55 divided by negative 5 is negative 11. So again, the set builder notation would be x such that x is everything less than negative 11. I believe in this case it asks for the interval notation next. I wish it asked for the number line next, because that's how I kind of think about the interval notation. The number line goes from negative 11, and then we're pointing in this direction. So we would shade everything from negative infinity up to negative 11, meaning this would be a closing parenthesis, meaning we go from negative infinity to negative 11, and that's the interval notation. Let's look at another example. Oh yeah, skip number 3. I was looking for 3. 3 is just kind of a weird one with the decimals, but you're just combining like terms and all that. People are going to ask about question 4. So let's take a look at this one here. We have, of course, 3 fractions. And we're going to solve this like an equation, but it'll just be an inequality. So again, this is like numbers 8 and 9 on section 1.2 that I just made videos on. Here, our LCD is 30. So I am going to multiply each term by 30. Multiply this one by 30. That'll be easy. So it doesn't really help us to use the calculator here because we have a binomial in the numerator. So 30, or 30 over 1, times 1 plus x over 10. And we do that division here. We divide diagonally, divide out the denominator. 10 divided by 10 becomes 1. Divide 10 here. 30 divided by 10 becomes 3. So now the denominator goes away. It's just 1 times 1. The numerator becomes 3 times 1 plus x. We distribute the 3 to get 3 plus 3x. Next, we have the minus sign, and then we're going to take 30 and multiply it to this x plus 1 over 6. Again, we divide out the denominator. 6 divided by 6 becomes 1, so the denominator is gone. 30 divided by 6 is 5. So we can think about it as a negative 5. If you have a plus sign here, yours is a bit easier. But here we have a negative 5 times x plus 1. Distribute the negative sign with you as you distribute to get negative 5x minus 5. Carry down our sign is greater than. So you see we're clearing out the fractions by multiplying each term by the least common denominator. And then this one is easy because negative 1 over 30 times 30 these cancel out, and it just becomes negative 1. You could also just put this in the calculator, but it becomes negative 1 over 1, which is just negative 1. And so now we have a basic inequality here. We have some like terms to combine. 3x minus 5x, and then a 3 minus 5. This gives us negative 2x. 3 minus 5 is negative 2. And this is greater than negative 1. We want the x on the left, so we'll add 2 to both sides. Negative 2x is greater than positive 1. Divide both sides by negative 2. I don't love that you often get a fraction here. 1 divided by negative 2, so it's a positive divided by a negative, but it's just negative 1/2. And if you're putting this on a number line, be very careful where you put the decimal. I'm seeing students get problems marked wrong for what appears to be just being like a 10th off. So you can think about it as x is greater than negative 0.5, which would be between 0 and negative 1 on a number line. So that would be right between them. X is everything greater than that. So we would have a parenthesis here and then shade to infinity. Oh, sorry. So negative 1/2 to infinity in interval notation. It might ask you for the set builder as well. So one last question that I'll go over. Here we go. Compound inequality, meaning two symbols. But these work out just fine. We're going to get x by itself, and we're going to work across each of the symbols here. So I add 6 in the middle, I add 6 to the 4 on the right, and I add 6 to this piece to the left of the less than symbol. So we get 7 is less than 5x is less than or equal to 10. Now we divide out the coefficient, and again we do it on in the middle and on the two sides of the inequality symbols. So we do get a fraction. In ALEKS, if it's asking for a solution like x equals 7/5, we think about it as a fraction. But here, since we're going to put this on a number line, we think about it as 1.4 is less than x is less than or equal to 2. So on a number line, we don't have a very big area to shade in here. Again, you have to be very careful where you put the decimal. So 1.4, 1, 2, 3, 4. We put a parenthesis there and a bracket at 2, and this is our shaded area. So, I hope that helps. Let me know if you have any questions.